Hello everyone, this is Rudra Muhammad Shoidullah here. Welcome to today's session where we deep dive into the basics of artificial neural networks and activation functions. Whether you are new to machine learning or just want a clear understanding of these concepts, this video will help you. So let's get started. In this video, we'll cover four major points. What is an artificial neural network or ANN? What are activation functions? Why do you need activation functions inside neural networks? And finally, different types of activation functions that are commonly used today. An artificial neural network is a machine learning system that mimics how human brains work. In our brain, billions of neurons are connected together and help us think, decide, and learn. Similarly, an ANN is made up of small processing units which can receive the information, process it, and pass it to other neurons, just as like human brain. The primary purpose of ANN is to learn patterns from data and make predictions based on these learned patterns. So for example, we can say recognizing handwritten digits, or predicting stock prices, or translating languages. These are all the tasks where ANNs are used. Now let's look at the basic structure of an ANN. So ANN consists of three main layers: the input layer, one or more hidden layers, and the output layer. The input layer, where the raw data enters the network, for example pixel of an image or words of a sentence, and one or more hidden layers where the real processing happens. Here neurons perform different calculations, recognize patterns, and transform data. And finally the output layer, where the final prediction or decision is made, like for example we can say classifying an image as a cat or a dog. Here we have an visual representation of a single neuron or a single processing unit. So we have input x1, x2, xm, and the associating weights w1, w2, wm. So we multiply the input x1 with the weight w1 and summarize all the inputs and weights, and gets an output which is a linear output. Then we passes the linear output onto an activation function, and the activation function then makes the non-linear output a non-linear output. So what is an activation function? An activation function is very important part of a neural network. It decides whether a neuron should be activated or not, meaning should it pass information forward or not. Technically speaking, it takes the output from a neuron, which is usually just a number, and transforms it into another value f of z. This transformation helps the network understand complex patterns like curves, images, voices, or text, etc. So why we need activation functions? If we didn't have activation functions, the network would just behave like a simple straight line, and no matter how many layers we add, it would still be a linear model. But in real world problems like face recognition, weather prediction, or language translation, these are non-linear and very complicated. Activation functions brings that non-linearity to neural networks, helping them to learn and solve complex problems. There are various types of activation functions. The most commonly used are sigmoid activation function, 10H activation function, ReLU activation function, and leaky ReLU activation function. Let's go through each one of them in more detail. So now let's talk about the sigmoid activation function. The sigmoid function is one of the earliest and most basic activation function used in neural networks. It takes any input value, whether it is a large positive or a large negative number or anything in between, and it compresses the values into range 0 and 1. The mathematical formula of the sigmoid function is function of x is equals to 1 by 1 plus e to the power minus z. When we plot it, it looks like a smooth S curve, because the output is always between 0 and 1. It's very useful for situations where we want to predict probabilities. For example, we can say in binary classification tasks like predicting a weather, or or an email is a spam or not, the sigmoid function is very helpful. Now let's quickly talk about the advantages and disadvantages. So what are the advantages of a sigmoid function? The main advantages is it's great for binary classification problems where we need a yes or no answer, and the output being between 0 and 1 makes it easy to implement, learn, interpret the result. And what are the disadvantages? Sigmoid suffers from something called the vanishing gradient problem. When the input values become very large or very small, the gradient or the slope of the curve becomes extremely tiny. This causes very slow learning in deep networks because the updates to the weights become almost negligible. So in simple words, sigmoid is helpful for binary outputs but can slow down learning in deep or very large neural networks. Now let's move on to the tanh activation functions, which is also known as the hyperbolic tangent function. The tanh function is quite similar to the sigmoid function because it's also an S-shaped card, as we can see here. But there's one key difference. Instead of squeezing the output between 0 and 1, tanh squeezes the value between -1 to +1. The mathematical formula is tan is function of x equals to e to the power z minus e to the power minus z divided by e to the power z plus e to the power minus z. When we plot tan h, we can see there is a curve that is centered at 0. It smoothly transitions from -1 to +1. Let's now quickly talk about the advantages and disadvantages of tanh function. So the main advantages are tanh function is zero centered, so it is very easy for it to optimize algorithms and converge quickly, and it usually performs better than the sigmoid function, especially in hidden layers of a neural network. So what are the disadvantages? The main disadvantage is it still suffers from some gradient vanishing problem. So when input becomes very large or very small, the gradient shrinks towards 0, which can slow down the learning, especially in the deeper networks. So we can say that tanh improves upon the sigmoid by being centered around 0, making it generally a better choice for hidden layers, but it still has some of the same problems when used in very deep networks. Now let's talk about one of the most popular and widely used activation functions, the ReLU, which is also known as rectified linear unit. ReLU is very simple. The rule is if the input is positive, then it just outputs the input as it is. So we can say if the input is 5, the output will be 5. If the input is 7, the output will be 7. And if the input is negative, the outputs are 0. So if the input is -5, the output will be 0. And also if the input is -7, the output will also be 0. So mathematically it is defined as a function of x, max of 0 to x, as we can see in the curve that if for positive inputs it is a 45-degree straight line, and for negative inputs it is flat 0. Okay. So why is ReLU so popular? So one of the main advantages of ReLU are it is computationally very simple and fast, so no complex calculations like exponents or divisions, and it helps to solve the major problem of tanh and sigmoid, the vanishing gradient problem for positive inputs, which means networks can train faster and efficiently. It works very well for deep networks, which is why most modern deep learning models use ReLU in hidden layers. However, ReLU is not perfect. It has some disadvantages too. If a neuron keeps getting negative inputs, its output becomes 0 and it may stop updating together. In other words, the neuron is dead and no longer learns. So despite all of that issue, ReLU remains a default choice in many deep learning architectures because of its benefits. Now let's move on to an improved version of ReLU called the leaky ReLU activation function. Leaky ReLU is designed to fix one of the main problems of ReLU, which is the dying ReLU problem. Remember, in ReLU, if the input is negative, the output is completely 0, and sometimes neurons can stop learning because they always output 0. This is where leaky ReLU comes in. In leaky ReLU, instead of outputting exactly 0 for negative numbers, we allow a small non-zero negative output. In simple terms, for negative inputs, the function gives a tiny slope instead of a flat line. Mathematically, it is defined as function of x is equals to alpha x if the input is smaller than 0, and function of x is equals to x if the output is greater than is equals to 0. Here alpha is a small positive value like 0.01. That means for negative number inputs we don't get 0, we get a very small negative number. So what are the advantages of ReLU? It solves the dying ReLU problem by allowing neurons to have small gradients even when the input is negative. It helps keep more neurons active and learning during the training process. Uh, so in simple words, we can say that Leaky ReLU keeps the basic speed and simplicity of ReLU but improves it by making sure neurons don't die out completely. And that brings us to the end of today's session. I hope this explanation made things clear and easy for you. Thank you so much for watching. Assalamu alaikum everyone.